Assalamualaikum everyone. Welcome back to chapter 2 per unit quantities. Today we're going to continue. We're going to do per unit for three-phase circuit. The previous class we already discussed per unit for single phase. So the difference between single phase and three-phase is on the equations. Okay, so if you remember, this is the symbol of a phase. Okay, and this is the symbol of the line. Okay, for phase, I always note it as this. Okay, it's always referring to phase. Okay, the symbol, and then sometimes I will write, for example, IL as line current. Okay, or I can also write it as line to line current. Okay, so that's the difference, okay, with the symbols. Alright, so for example, okay, this is the most important formula for the current, the line, and the phase current is the same, but for the voltage, okay, the voltage phase is equal to the line voltage divided by square root of 3. Okay, so you have to remember these two formula. It's very important. And then you have to note that, okay, when you want to calculate the S base, this is the formula. Okay, all right, and of course for this one, V base is equal to VL. Okay, right. So next is the equations of the power, okay, where you can see here S per unit is actually equals to S three phase, okay, divided by the base, and then you get as V per unit, because remember this is per unit, okay, so you have to times by voltage per unit and current per unit. Okay, alright, so what's very important from this equation that you can see here in the three-phase system, you have to know that the V phase per unit, per unit always equal to the V line per unit. Okay, because they are in per unit, so they always equal. Alright, and you remember the per unit formula. Okay, let's revise again. Per unit formula is actual divided by base. Okay, so it doesn't matter if it's current per unit, means that current actual divided by the current base. If it's voltage per unit, it's voltage actual divided by voltage base. If it's resistance, is okay, is R per unit, okay, equals to R actual divided by R base. Okay, remember that from the previous class. Okay, so let's do example 2.8. Okay, in this example, you have a balanced system. Given your power for three-phase base as 30 mega VA, and then VLL means that line-to-line base voltage is 120 kV, and you have a line-to-line actual as 108 kV. Alright, then you have power for three-phase actual as 18 megawatt. Alright, so let's find for A. Okay, so if you see here, okay, if you're still not aware, you see I wrote as VLL. So this means line to line voltage. Okay, and in the question, okay, here, if you see, is VLN, yeah? So what it means? It means line to neutral. Okay, what does this mean? Okay, when you say line to neutral, automatically this means V phase. Okay, alright. So do you still remember the formula? V phase formula equals to VLL divided by square root of 3. Okay, V phase is this one, yeah, guys? Okay, that is a V phase. So this is the most important formula for you to remember. Okay, alright, in this exercise. Okay, so let's solve, okay, A, where you have to calculate the power for one phase. Okay, you are given the power for 3 phase. Okay, so if you want to get the power for one phase, base, so you just have to divide by 3. Okay, alright, so for question A, you want to know, okay, the power for one phase base. Okay, you know the power for 3 phase base, so you divide by 3, so you get that as the by 3, you get that as 10. Okay, fantastic. And the next, okay, you are asked to calculate VLN base. Okay, again, remember when I say VLN, okay, line to neutral, this means is a phase. Okay, phase voltage. So how to solve phase voltage? Okay, you are given, you know this formula. Okay, so you know your VLL base as 120 kV, so you divide by square root of 3, and you get as 69.2 kVA. Okay, C, you are asked to calculate VLN actual. Okay, so again VLN is the V phase actual. So V phase actual is given as the formula VLL actual divided by square root 3. Okay, so you know VLL actual is given as 100 kV divided by square root of 3, and you get 62.3. Okay, alright, and D, you are asked to calculate VLN PU per unit. Yeah, so you know your VLN, remember per unit formula, actual divided by base. Okay, so VLN base. Okay, you get that as 62.3 divided by 69.2. Okay, of course the unit get cancelled out, then you get that as 0.9 PU. Okay, so that is D. So let's move on, okay, to the last question, which is E. In E, you are asked to calculate, okay, the per unit, you are asked to calculate per unit power for one phase. Okay, alright. So if you look back, okay, that's what you are asked, per unit of power per phase. Okay, so means that you need to calculate, okay, for one phase per unit. Okay, that's what you have to find. Okay, so you know, in order for you to calculate, okay, the power for single phase per unit, okay, you need to know, okay, the power for single phase actual divided by the power for single phase base, yeah, that's what you need to know. But you are not given these two, okay, you are not given the S for single phase actual and S for single phase base. So it means that you have to calculate, okay. So let's calculate for power for single phase actual first. Okay, so you're given the power for three phase actual, right? In the you in the previous question, in the question, and so you divide by 3, and then that you get a single phase, yeah. That is 6 megawatt, and then next you calculate the single phase for the base. Again, of course, for the the power for three phase base, okay, which again you are given as 30 megawatt. Then you divide by 3 because you want the single phase. Okay, so you get 10. Okay, so now you can calculate the S for single phase per unit, yeah, where the actual, you take the actual, divide by the base. So 6 divided by 10, and you get a 0.6 per unit. Okay, so that is for example 2.8. Alright, so let's move on to the next example, 2.9. In this example, it's actually related to example, the previous example, example 2.4. Okay, so this is basically the circuit that we're going to look into, except that we don't have, okay, the transmission line here in the middle. Okay, we're just going to consider the source and also and the load. Okay, we don't have this, we're just going to consider this and this part, okay, as PS, okay, and then this as the load. All right, okay, so this is what it means by three phase, okay, Y connection, okay, identical impedance of 20, okay, so this part, okay, ZL, okay, this is the ZL, okay, and the base of 4.4 kV line to line and 137 ampere. Okay, right. And then, oh yeah, this is very important. Okay, so both voltage and current has to be 1 per unit. Okay, and you are given your ZL as 1.4. Oh, sorry, means that you do have ZL, sorry. I thought you don't have ZL. Okay, yes. So you're given ZL, so ZL, we do have ZL. Sorry, this is Z load, not ZL. Okay, so the ZL as, this is the ZL as 1.4. This is the Z load. Sorry, yeah, guys. Okay, so they ask us to find the VS, okay, by using per unit. Okay, so let's solve this example. Okay, so we have to find the VS. Okay, we know our ZL as 1.4 ohm, and we know our load. Okay, we are given that. Okay, so the first thing what we have to do is find Okay, the base, okay, for Z I V, okay, for single phase first. Then this is because in order for us to find VLL, okay, per unit, we need to know this value first. Okay, in order for us to find this, we need to know this first. Okay, so we also need to know the ZL base. We need to know I actual, and also we need to know V load actual. Yeah. Okay, so step 1. Calculate the V load first. Okay, alright. So let's calculate the V load for one phase. Remember the formula, okay, divide by, okay, remember the formula of the single phase. Okay, this is the formula, yeah. Always remember this formula. Okay, so you know your V load, okay. V load LL is given as 4400 divided by square root of 3. Okay, and 254. Okay, so next we calculate the V load per unit. So V load per unit, remember the per unit formula, V load actual divided by V load base. Okay, so that is the one that we just calculated. Okay, remember previously it says that the voltage needs to be in 1 per unit. Okay, so the question already give you a hint. So means that the voltage here has to be in 1 pu. So in order for it to be 1 pu means that it has to, the V load base has to be 2540 as well. Okay, so we get that. Okay, so let's calculate for I actual. So I actual is V actual divided by Z actual, yeah. So in here, we are taking V load actual, which is 254, okay, divided by 20. This is given in the question, yeah. This is the Z load, okay, because this is the Z load, and this is the V load actual, yeah. Alright, so after you solve that, you get 127 negative 30 ampere. Okay, so let's calculate for I actual PU. I actual PU is I actual divided by I base. So we calculated that I actual, and then again remember, okay, from the question we need to maintain the current as 1 per unit, okay, because the question asks so. So that's why, okay, so here has to be 1 per unit because that's what the question wants. So it means that we have to divide by the same, okay, in order for us to get 1 PU. So let's put that as 0, okay, and then shows negative 30. Next, let's calculate the ZL. Okay, ZL base is V load base divided by I base. Okay, so it's given by 2540 divided by 127 equals to 20. Okay, so if you see here, okay, I just want to make a quick note. Alright, I'm taking both current and voltage for base, okay, as 0 degree. It's always, okay, it's always 0 degree for current and voltage for base, okay. So ZLPU is ZL actual divided by ZL base. Okay, so that is 1.4. This given in the questionnaire divided by 20. So that gives you 0.07 PU. Sorry, this is 75, not 7.5, 75. So now, after having all this information, we can calculate the VLL, okay, as what the question wants us to calculate. Okay, so for the single phase, VS, okay, so VS for single phase, we are given the formula as IZL plus V load. This is the Kirchhoff voltage law, yeah, KVL. And you know your I actual PU times by ZL PU plus V load PU is 1, okay, 0.07 plus, okay, and you solve that, you get J 0.0495. Okay, and do you still remember to how to convert from polar form to rectangular form? Okay, good. If you do remember, okay, so this is in the rectangular form, yeah. Okay, so this is for single phase. Okay, so this value is for single phase.